So let's take a look at this question, which is asking us to perform a hypothesis test for the mean of one population. Reading the question, we have a data set includes data from student evaluations of courses. The summary statistics are n equals 97, that means the sample size, x bar equals 3.85, that's the sample mean, and s equals 0.54, that's the sample standard deviation. Use a 0.10 significance level to test the claim that the population of student course evaluations has a mean equal to 4.00. Assume that a simple random sample has been selected, identify the null and alternative hypothesis, test statistic, p-value, and state the final conclusion that addresses the original claim. So first we're going to see what the null and alternative hypothesis are. So let's look again at our claim. Recall, the claim was up here. They told us to test the claim that the population of student course evaluations has a mean equal to 4.0. A mean equal to 4.0. So if we were going to write this down, remember that the mean is represented with this symbol, and we want to say that is equal to 4.00. So this is our claim. So I like to just put next to it claim. Now remember, anytime we have a hypothesis test, it's important that we have to know that the statement that has an equal sign in it goes in the null hypothesis. So this statement right here has to be our H0 statement because that is the null hypothesis with the equal sign in it. Well then, for the alternative hypothesis, if the claim and the null are that the mean is equal to 4.0, then the alternative is going to be, well, then it's not equal to 4.0. So now we have our null and alternative hypothesis for this test. Looking at all the different options, that's going to be letter B. Now we want to determine the test statistic for this particular test. We can do that in Statcrunch very easily. So we're going to go down here to get more help, and we're going to open up Statcrunch. So all the hypothesis tests that we do in this class are going to be under the stat key. For this one, we are going to select t-stats. Why are we selecting t-stats? Because we're going to use the t-distribution to find the values that we need to make a conclusion about this test. And we know that because we're doing a test about a mean, and the standard deviation we were given came from a sample. Those are the two things that we need to see to know that we're using the t-stats. We're doing a test about a mean, and the standard deviation we were given came from a sample. So we're choosing t-stats here. We were only given the information from one sample here, so we're going to choose one sample. And we're going to choose with summary because recall they gave us the n, the x bar, and the s values here already summarized for us. They did not give us a set of raw data to work with. So we're going to choose with summary. So now we need to go ahead and put in the information that they gave us. So the sample mean, recall they gave us here, that's the x bar, that was 3.85. So 3.85. for the sample mean. The sample standard deviation is the S, that was 0.54, so we're going to put in 0.54 for the sample standard deviation. The sample size is denoted by N, so that was 97. So we're going to go ahead and put in 97 right here. We're going to leave this box checked for hypothesis test because we were trying to do a hypothesis test, and recall that the value here that we were saying the mean was equal to was 4.00. So we're going to change this to 4.00. Notice that when you changed it here in this box, it automatically updated here. For the alternative hypothesis, remember the alternative hypothesis that we correctly had was that the mean is not equal to 4.00. So we can just leave this set to not equal to 4.00. But notice if there was a different alternative hypothesis, we can change it to less than or greater than, whatever we need to do. That's it. So we're going to click compute at the bottom. And this t-stat value right here in the second to last column, that is our test statistic. So I'm going to go ahead and copy that and bring that all the way over here to our test statistic column or answer field. And this says to round to 2 decimal places. So if we start at the decimal point and go 2 after that, 1, 2, we're at this 3. We look 1 point further to the right of that and we see a 5. The 5 means we round up, so we're going to round that 3 up to a 4. Next, we needed to get our p-value. That was also provided to us from Statcrunch. You see the p-value right here. So that's this number. So we're going to copy this. And again, bring it over here and paste it. This is asking us to round to 3 decimal places. So after the decimal point, 1, 2, 3 is a 7. We look after the 7 and we see a 4. 4 means we round down, which means we're going to leave that 7 as just a 7. So now we want to state the final conclusion that addresses the original claim. So the p-value, remember, was right here, 0.007. And the significance level that we started with was 0.10. So remember the p-value is 0.007. And the significance level, which we call the alpha, was 0.10. So what we want to know now is which one of those values is bigger. Well, in this case, the alpha is bigger, right? The p-value is much smaller than that alpha value. So when the p-value is smaller than alpha, the decision is to reject H0. So here we're going to choose to reject H0. Well, what does that mean? So if we reject H0, coming back up to our hypothesis originally, the H0, remember this was our claim originally. We wrote that down at the beginning. The claim was that the mean was equal to 0.4. We just decided to reject that statement. So if we're rejecting it, I like to cross it out. I reject it, I don't like it. Well, if I reject that, then by default, I have to give support to the other statement. So I like to circle that one so that I can see visually which statement I am accepting as being supported and which one I am rejecting as not being supported. This one, notice that we had crossed out our claim. So that means we did not support the claim in this instance. So when I come down here, what I need to say is there is sufficient evidence to conclude that the mean of the population of student course evaluations is equal to 4.0 is not correct.